Okay, so horizontal asymptote happens in two occasions. Okay, so when you have a rational expression, let's say you have px over qx, when the degree of the top is lower than the bottom. So for example, you have like x plus 1 over x squared plus 1. Okay, then the horizontal asymptote is going to be the x-axis. If, okay, so if p at x, in this case, if the degree of the p at x is equal to the degree of q at x, for example, okay, then the asymptote is not the x-axis, it's the coefficient, the division of the coefficient. In this case, it's 1. Okay, so all of these, eventually they're going to approach the asymptote somehow. Okay, so when do graph look like this one? So this happens if there's an x-intercept that's away from the origin. Okay, so for example, the way I can create that is something like this. Okay, so this one here has a horizontal asymptote. Let's say this is around the origin. So let's say we have an x plus 1, right? X plus 1, let's square that. And it has an asymptote at the x-axis, except there's an intercept, okay, all the way over here. And this, for this particular graph, it also has an intercept all the way over here as well. Okay, there's one that's kind of close, so let's say that's like x minus 3, and there's another one all the way to the left, like x minus 100 or something. The basic outline of this graph is that it's got x-intercept at 3, and all the way at negative 100, and a vertical asymptote right here, and it's also got a horizontal asymptote. Okay, this is a graph before negative 100, it's positive. Okay, it's positive. So, but it has to pass through there, so it's positive, but it has to approach the asymptote, so it has to go back down. Between negative 100 and 3, it's always negative, right? So this is gonna do this. It's gonna approach the asymptote here this way. Okay, that's not to scale. It's also negative from negative 1 to 3, so it's gonna be like this, right? It's gonna go back up and then come back down again because it has to pass through here, and we have to start from the bottom, right? And come back down and approach the horizontal asymptote. So I hope that makes sense. What we have here, right, is a graph where it passes through the x-axis because we have x-intercepts there, but because we have a horizontal asymptote, when it goes up, it must come back down. Same here. When it goes up, it must come back down.